Hello everyone, welcome to my calculus lecture. In this lecture, we study derivatives. So what is a derivative? Derivative is a crucial notion in calculus, particularly in differential calculus. Derivative could mean a lot of things depending on the context. So, its meaning could be different when we talk about derivative in a purely mathematical sense, or in physics, or biology, or in engineering, or, in, many other places, in economy even. Uh, right, so purely mathematically, it is the slope of a tangent line to the graph of y equals f of x at a point x equals a. In principle, though, you know, the slope of a tangent line can be found by algebra, but in practice, it can become an extremely difficult task with algebra alone. Uh, we are not going to delve into that. For details, please see my lecture note at the following address. Okay, again, this address is hyperlinked, so you don't have to copy, paste, or write it down. Okay, you just need to click on this link, okay, to get to the note. Okay, so what we are going to talk about next is finding the slope of a tangent line due to Sir Isaac Newton and Gottfried Leibniz. So this method was discovered by Newton and Leibniz independently. It's quite an ingenious idea. So we want to find the slope of a tangent line to the graph of y equals f of x at x equals a. That's what we want to do, okay? So first, right, let us take a look at the picture here. So we are going to consider the line segment PQ, where P is given by A, f of A, and Q is given by A plus H, f of A plus H, okay? Right. So, as seen in the following picture, right? So, we're talking about this line segment in blue, right? In blue, okay? Joining 2 points P and Q. So we have no problem finding slope of tangent line. I mean, the slope of this, the line segment PQ, okay? Using the formula we learned in algebra. Okay, so let me move to my notepad. So here, the point P is given by the coordinate A, f of A, and Q, A plus H, f of A plus H, right? Okay, so let's call this x1, y1, x2, y2. So in that case, the slope of the line segment PQ is, as you will remember, right, in the case, the slope is given by y2 minus y1 all over x2 minus x1, right? So we have f of, so y2 is f of a plus h minus f of a all over x2 a plus h minus a. So that comes to f of a plus h minus f of a all over, right? This a minus a, that will cancel out, leaving only h, right? So this is the slope, okay? That's the slope of line segment PQ. So have that in mind, okay? So let's go back to my lecture slide. So that's what we have here, okay? The uh, slope of the line segment PQ. Here I see a typo. So the line segment PQ is this f of a plus h minus f of a all over h. Now, we're going to do some experiment here, okay? So next, what we are going to do is to observe what happens to the slope of the line segment PQ as h gets smaller and smaller close to 0. In other words, we are going to move h closer to 0. In other words, let me go back to previous page. Right here. So in other words, h, we're going to take h smaller and smaller value close to 0, means that this a plus h gets closer to a, right? That's what happens. In that case, what we are going to see is how this line segment changes, or quantitatively what's going to happen to the slope of this line segment, okay? But also we want to see visually what happens to this line segment PQ, okay? Right. Yeah, you might find the kind of funny to hear about like experiment when we talk about mathematics, but actually that's quite useful, okay? We do occasionally like do experiments even in mathematics, okay? uh, yeah, it's fun. Okay, so let's go. So first, we can't do that kind of experiment with this, generic, like, the slope, okay, right? I mean, those are not actual numbers, right? These are like A and H, they all represent, number, but generic, in generic sense, right? So we can't do experiment with like generic quantities, right? So we are going to use actually a particular example, okay? Example. So in this case, what we are going to use is f of x equals x squared, something simple, and a equals 2. So in that case, the slope of PQ, right? PQ is given by f of 2 plus h minus f of 2 all over h, which is 2 plus h squared minus 4 all over h. So that's the quantity we are going to use for our experiment or observation. Okay, right. So here we go. So first, we are gonna start with h equals 1. So this is what happens. Actually, that's the line segment PQ, right? In color blue, right? I actually extended it to line all the way to the here, right? All the way here. There's a reason for that, okay? So that like I want to see like how this line behaves, you know, better, right? So that's what happens, okay? Now we are going to take a smaller h value. So moving on. So this time we are going to choose h equals 0.5. Okay, h equals 0.5. You see what happens? Okay. I don't know if you have noticed, but for me, I think this blue line gets closer to red line, okay, than previous case. You see that? Oh, by the way, I forgot to tell you what the red line is, right? Red line, as you actually noticed, you might have noticed, right? That's the tangent line because what? This red line is touching the 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 curve in black, right? Curve in black. That's the part of y equals x squared, and so it is touching the graph of y equals x squared at exactly at one point, right? That's what it does. So this red line is actually line tangent to y equals the graph of y equals x squared at x equals 2, right? So as you can see, when h gets smaller to zero point 0.5 from 1, the blue line gets closer to red line, okay? Now this time we are going to choose h equals 0.1, even smaller value, right? And as you can see, the line in blue gets even closer, right? Closer to the red line. And now this time I'm going to choose a much smaller value, okay, of h and more closer to 0, right? So that's going to be h equals 0.001. Let's see what happens in our eyes, right? In our eyes, I mean, you know, to our eyes, the blue line and red line, they overlap, okay? They overlap. So, to our view, we can't distinguish them. They just overlap, okay? Uh, they don't, they don't, but, to our eyes, okay, to our view, they look like, they overlap. Of course, because, you know, it's a, yeah, our eyes, can't see the gap between them. Okay, they are too close. Okay, so you see what's going to happen? We can continue doing this, right? We can continue doing this. So when h are going to get even smaller and smaller, so eventually, like you know what's going on. We are going to take the limit. Okay, so this is actually limit process, but I picked like some the sample points, right? Okay. But imagine that like so we change it continuously h to 0. So they take the limit. So what's going to be the limit of the f of a plus h minus f of a all over h, right? The quantity slope of the line segment PQ as h goes to 0. As you can see from our little experiment, the little observation, right? The line segment gets closer and closer to the tangent line. So of course, when h goes to 0, the limit is going to be exactly the slope of a tangent line, right? Okay. So slope of the limit of slope of the line segment PQ is going to be exactly the slope of tangent line, right? So that's the idea, invoked by Newton and Leibniz, independently. That's quite ingenious, okay? That's quite ingenious. So here we go. We got it, okay? So that's the derivative. So earlier I mentioned that derivative is the name for, right? Name for, the finding a derivative of, the finding the slope of, the tangent line to the graph of y equals f of x at particular point x equals a, right? Okay, so that's called the derivative. So the derivative of y equals f of x at x equals a is given by this, right? Again, like we mentioned just now, uh, we denoted by the way, derivative is denoted by this notation here, f prime of a, f prime of a equals limit of this quantity here, okay? So geometrically, there was the slope of line segment, right? Okay, f of a plus h minus f of a all over h. Okay, when h goes to 0. When h goes to 0, this limit is the slope of tangent line, and the name is derivative. Okay, the derivative of y equals f of x at x equals a. F prime a, f prime of a, so the derivative can be also given by this formula here. So how do you get that? Okay, so to explain that, let me go back to my notepad again. So here's the derivative, right? So f prime of a, okay, so that's the original definition. So limit of f of a plus h minus f of a all over h when h goes to 0, okay, when h goes to 0. By the way, before we go, this quantity here, so there was what slope of the line segment PQ. That's in geometric sense, right? But this quantity can come with like a lot of different names. Okay, so it's a generic name in mathematics. It's called the finite difference. Okay, finite difference. I mean, it's not important. Okay, it's not important, but you might hear uh, this terminology, finite difference. Okay, so you know, I just want to tell you that. But also depending on the context, okay, it could mean, say, in physics, it could also mean like average velocity or average acceleration. So it could come, depending on the context, like a lot of different names also. But its generic name is finite difference. All right, so let's let, so in this definition, okay, so let x be a plus h, okay, a plus h. So what I'm gonna do is rewrite this definition in terms of this new variable x, all right? So what happens then, if you solve this for h, right, again, what we are going to do is rewrite this definition in terms of new variable x, okay? So we are not gonna use h anymore. So if you solve this equation for h, we get like h equals x minus a, okay? And also, when h goes to 0, what's going to and what happens is when h goes to 0, x goes to a, right? Obviously from this equation, so we know that x goes to a, x approaches a as h approaches 0, okay? H goes to 0. So we've got that. So, we have everything that we need. So, here, f prime of a equals limit f of, instead of a plus h, f of x minus f of a all over x minus a. Instead of h, x minus a. And here, instead of h goes to 0, we have x goes to a. That's it. So that's how we get the alternative definition of a derivative. So actually, when you actually calculate the derivative, you can use either definition. All right. It's just a matter of personal choice, right? If you ask me, like, which one you want to use, that's your choice. Um, when it comes to like a derivative of a polynomial function, right? So they are associated with like two different type of like the algebra operations. Like first one, you are going to expand a polynomial. This one, you are going to factor a polynomial. Sometimes factoring is easier than the expanding. Okay, then we're gonna see that, like from an example later on. So let me get back to my lecture slide. Okay, so here they are the examples. Okay, first example, find the equation of a tangent line to the graph of f of x equals x squared at x equals 2. Okay, so equation of a line, no problem, right? So what do you need? You know, from algebra, you learn that to find the equation of a line, you need two ingredients, right? One is slope of the line, and the other one is what? You need to know one point on the line, right? So once you know the slope of the line and also one point on the line, you can determine the equation of the line. Okay, no problem, right? Okay, so the so here, like what what we need is find the slope. The slope of the tangent line can be found by finding the derivative, right? Finding the derivative. Okay, so to work it out, we are going to go back to my notepad. So here, okay, so example 1. Find the equation of tangent line to y equals x squared at x equals 2. Okay, let me actually change it, y by f of x. Okay, right. So here slope. So slope is going to be. So I'm going to write down those two ingredients I mentioned, right? Slope is going to be f prime of 2. Okay, that's the derivative of this function, right, at x equals 2. That gives us, right, gives rise to the slope of this tangent line. And we need a point, right? That's a piece of cake because at x equals 2, so x coordinate of the point is 2. Okay, and y coordinate is going to be f of 2. So which gives us 2 comma, when f of 2 equals what? 2 squared 4. So we got 1 point. So really it gets down to, the finding this derivative, okay, right, which is slope, which is the slope, right, of this tangent line. Okay, so in that case, the equation of tangent line is going to be given by the following equation, right? Y minus y1, 4 equals slope f prime of 2 x minus x1, which is x minus 2. Remember this formula, right? Okay, from algebra, right? Okay, so let's get to finding f prime of 2. So that's by definition limit. I'm going to do this in two ways, okay? So using the original definition and then also use the alternative definition, okay? To show you the difference. So limit h goes to 0, f of 2 plus h minus f of 2 all over h. So that equals limit h goes to 0. So f of 2 plus h is 2 plus h squared minus f of 2, 2 squared, which is 4 all over h. Now, as I mentioned earlier, in this case, we will have to expand this guy here, 2 plus h squared. Not a problem, right? That's a piece of cake, okay? So 2 plus h squared, that's 4 plus 4h plus h squared minus 4 all over h. So we cancel 4 out, okay, 4 minus 4. And then what? Also, top and bottom have h in common. So we are going to cancel 1h out. I mean, canceling means that actually we are dividing top and bottom by h, right? So this leaves us limit h equals to 0. So what's remained is just the h plus 4. Now when h goes to 0, what's going to happen? The limit is going to be 4. So we found it. Okay, we found it. That's the slope. Okay, that's the slope. So f prime of 2. So now we are ready to write down the equation of a line. That's going to be y minus 4 equals 4 times x minus 2, right? X minus 2. So that's the equation. But we don't want to leave it like this, okay? Right? In fact, always what the line what do you call it? The slope, y-intercept form, right? Slope y-intercept form. Oh, yeah, I was out of space. Yeah? Come on. So slope y-intercept form. That's what? Y equals ax plus b. Okay? So we want to write it in this form. So here, a is the slope and b is I don't know. You actually I mean it doesn't matter, but I said like a is a slope, but I think in algebra you guys used it just m for the slope, right? So mx plus b. Okay, whatever. So let's go back to this. So we are going to write it this way. That's just simple algebra. So from this, if you solve it for y is going to be 4x. Okay, 4x. 4 times negative 2, negative 8, when you move it, the negative 4 to the other side. That's actually, not even mathematical, but, if you actually add 4 to each side, you get what? Negative 8 plus 4 minus 4, okay? And that's 4. Okay, so that's it. So that's the slope of, that's the, equation of a tangent line 2, y equals x squared at x equals 2, okay? Right. So now this time we are going to use the alternative definition to find the f prime of 2. Okay, so this time we want to use the alternative definition. Okay, so f prime of 2 equals limit x goes to a. In this case, a equals 2, right? F of x minus f of a, which is 2, all over x minus a, which is x minus 2. Okay, so now this equals limit x goes to 2, f of x equals x squared minus 4 all over x minus 2. So as I mentioned earlier, now you can see that in this case, instead of expanding, you will have to factor this polynomial, right? We have seen this kind of thing before, right? In my earlier lectures, that's the 0 over 0 type indeterminate form, which can be determined by, simply by factoring, right? So x squared minus 4 is factored to x plus 2 times x minus 2 divided by x minus 2. Now again, remember, when we say x approaches the number 2, right, x gets closer and closer and closer to the number 2 indefinitely. It's like what, that imaginary like arrow, which keeps getting close to like the target, but it never hits the target, right? Okay, and so just like that, x is never equal to 2, no matter how it gets closer to 2, but it never becomes 2. So x minus 2 is never equal to 0, which means that we can divide top and bottom by x minus 2. So we say like, we cancel x minus 2, right? Actually, that's, totally unmathematical way of saying, but, that everybody understands it now. Okay, so limit x goes to 2. Now what's remained is x plus 2. And in this case, that's going to be 4, right? Okay, so we get the same thing, of course, right? So I don't know, some of you might find this easier, right? But again, like, it comes down to, the personal choice, personal preference, like whichever definition you use, okay? Right. Okay, so we have another example. Let's go back to check what it is, right? So same question, but in this case, f of x equals x to the 5th. Okay, x to the 5th, x to the 5, all right? Okay, x to the 5 at x equals 1. Actually, this looks pretty much like, similar, right? Okay, the simple. It looks pretty simple, but, actually it gets a lot complicated. Okay, a lot complicated. In fact, if you read my note, you would, my lecture note about the finding the slope of tangent line using only algebra. This is doable. Okay, this is doable. I'm not going to again delve into that. You will find out, if you read my note. But this is doable using just algebra. this is impossible. Okay, we can set up the equation, but then it's impossible to solve the equation. Like yeah. It depends. It depends. It's either extremely difficult or impossible. So that's why the those two big guys, the Newton and also Leibniz, they had to devise another method, okay, which is quite ingenious again, right? To find the slope. Okay. Anyway, so let's take care of this. Now we have the excellent the tool, okay, machinery to allow us to find the slope. So we are going back to my notepad again. So here's example 2. Example 2. Find the equation of tangent line to f of x equals x squared at, oh no, sorry, not x squared, that was the earlier one, x to the 5, right? Okay, x to the 5 at x equals, I think it was 1, right? X equals 1. Okay. So here's solution. So again, we're going to write down the ingredients. Right, the slope is f prime of 5, okay? And a point, that's going to be 1, f of 1. So that's 1, 1, right? 1, 1. Okay, and so in the case, the equation of tangent line is given by y minus 1 equals f prime of 5 slope times x minus x1, which is x minus 1. Okay, so it comes down to finding this derivative. So f prime of 5. Okay, here again I'm gonna do it in 2 ways. Okay, so using the original definition, limit h goes to 0, f of a plus h, 5 plus h minus f of a. Sorry, is that right? Oh yes, it is right. F of 5. Okay. Something tells me oh, I don't know what I was thinking. No, a equals 1, so I don't know why I got confused. Okay, so f prime of 1, that's the slope, right? Sorry about that. Okay, here too, f prime of 1 1 plus h, f of 1. Okay, good. So far, so good. Divided by h. So that's going to be same as equals limit h goes to 0, f of 1 plus h, that's 1 plus h to the power 5 minus f of 1 is 1, right? All over h. So now, we will have to expand this guy here, right? 1 plus h to the 5. So we remember, like, say something like what? A plus b squared, a plus b cubed, but what about, a plus b to the power 5? How do we expand it? I mean, expanding it like is not a problem, right? But is there an easier way to do? Yes, there are. Okay, yes, actually there is. So before we continue here, right, I'm gonna talk about something. Maybe I'll do that, like in a separate page. Okay, so there's a thing called Pascal's triangle. Okay, Pascal's triangle. So what you really need, to expand it, polynomials like, so a plus b to the power n, right? Okay. So in general, like, there is formula for that, which is called the binomial expansion. Okay, let me write down. So binomial expansion. So using binomial expansion, we can actually calculate this. I'm not going to talk about that though here, but you can actually find it. You can find the formula in my lecture note. Okay, about the discussion we are having here, right? Okay, so you will read about that. But there's an even more easier way to do. What really matters is the coefficient. So we just want once you figure out the coefficient, then the rest you can easily write it down. And interestingly, the coefficient of the expanded polynomial can be found by something called the Pascal. Oh, sorry, I forgot C. Let me rewrite that. Pascal. Okay, Pascal's triangle. Pascal this is named after the famous French mathematician. He was not actually a professional mathematician, an amateur mathematician. But when I say he's not professional, means that like he was not professionally trained mathematician. Okay, but I mean his contribution to mathematics is just just humongous. He's the guy also who invented the branch of mathematics called the probability. Okay, probability because he was interested in like what the winning, say like the card games, gambling. Okay, so that's what I read. That motivate him to think about the probability. Okay, interesting. So what is this Pascal's triangle? Uh, Here's how it goes. So the one. So start with one. Okay, and then next. So what happens is that this corresponds to a plus b to the power 0. Okay, so actually, what? I'm gonna just use it only the power exponent. Okay, only the exponent. So this is n equals 0 case. Okay, n equals 0 case. So this gives the coefficient of the expanded polynomial when n equals 0. Obviously, when n equals 0, no matter what a plus b is, it's going to be just 1, right? As you know. And then next, we're going to put 1 each line, each end, okay? Right? So that's going to be the coefficient for the case when n equals 1. So n equals 1 is a plus b, so coefficient is just 1, 1, right? No problem. Okay, and then, the next, we put 1 each side, each end again. And then, for these two guys, we add that 2, that goes in the middle, okay? So we have 1 to 1. And that's the case for n equals 2. So these guys give rise to the coefficient when you expand this. So how do we expand it using this information? First, a squared, and next one plus 2 times now what the exponent for a is reduced by 1, and you increase the exponent for b. So we have ab, right? Remember, in that case, so for each term, the sum of all the exponents has to be exactly the same as n, so 2, right? So in this case, 2, b equals 0, okay? I mean, the exponent for b equals 0. 1, 1, adding those two, 2, and next one is going to be when a equals 0, the exponent for a equals 0, and then b for the exponent for b is 2. So we have b squared and coefficient equals 1, b squared. Okay? Right. And you can continue on. So, now for n equals 3 case, we put 1 each side again, each end, right? Each end. And then what? Between these two, for these two, we add. So that we get 3, we add these two, we get 3. So 1, 3, 3, 1, that's going to be coefficient when you expand a plus b cubed. So a plus b cubed is going to be same way. A cubed plus 3 times a squared b plus 3 times ab squared plus, remember the sum of all exponents, right? They have to be same as 3, and then b cubed. You can continue on. So for n equals 4, right? So you put 1 at each end, add these two, that's 4, this is going to be 6, that's 4. So 1, 4, 6, 4, 1, okay? That's it. So when you expand it, a to the 4 plus 4 times a cubed b plus 6 times a squared b squared plus 4 times a b cubed plus b to the power 4. That's the expansion of a plus b to the 5. Okay? I mean, easy, right? Okay? So you don't really have to use a binomial expansion. You get the exactly same thing. So one more actually, because we need that for our problem. So when n equals 5, we do the same thing. 1 each side, right? Each end, and then add this to 5, add this to 10, add this to 10, and add these to 5 again. Okay, so the expansion is going to be, in this case, so a to the 5 plus 5 times a to the 4 times b plus 10 times a cubed b squared plus 10 times a squared b cubed plus 5 times ab to the power 4 plus b to the power 4. The exponent is 5, right? Okay, so that's the expansion. No big deal. So now actually, you can continue on regardless of what n is, right? So, this goes like, the triangle. So that's called the Pascal's triangle. Okay, so now let's go back to earlier problem. No, actually, this. Okay, here we are. So we have no problem now expanding this, right? So limit h goes to 0. 1 plus h to the 5, we can expand it, no problem. That's going to be 1 plus Yeah, it goes like 1, 5, 1, 5, 10, 10, 5, 1, right? 1, 5, 10, 10, 5, 1. So 10, 1, 5, 10, 10, 5, 1. Uh, 5H, 10, H squared, uh, 10, H cubed plus 5H to the 4 plus H to the 5 minus 1. Okay, that's what we have. Uh, right. Okay, divided by H, divided by H. So let me confirm that. 5, 10, 10, 5, right? 5, 10, 10, 5. Okay. Right, so we can cancel this one out. Then remaining, the polynomial, right? So, the numerator and the denominator have h in common. So we can divide the top and bottom by h. That gives us 5 plus 10h plus 10 squared plus 5h cubed, right? Plus h to the power 4, okay? So what's the remainder? So that's going to be limit h goes to 0. So what's the remainder is 5 plus 10h plus 10h squared plus 5h cubed plus h to the power 4. So when h goes to 0, these guys all go to 0. Okay, that goes to 0, this guy goes to 0, and this guy goes to 0 also. Excuse me. And what's the remainder is just 5, right? So slope is 5. Okay, slope is 5. Okay, so the equation of tangent line is going to be y minus 1 slope equals 5, right? X minus 1. Again, we want to write this in the slope intercept form. Okay, y equals mx plus b type, right? Form. So, if you solve it for y, that's going to be 5x minus 5, and you add 1 to each side, that's going to be negative 4, right? Minus 4. So 5x minus 4, that's going to be the slope of tangent line. Okay, so lastly, I want to do again, like, the calculate this f prime of 1 using the alternative definition, okay? So let's do it here. So here, we want to calculate f prime of 1, right? Using the second definition. So limit, in this case, x goes to a, which is 1, f of x, right? F of x minus f of a, which is f of 1, all over x minus 1. So limit x goes to 1. F of x is x to the 5 minus 1 over x minus 1. Well, in this case, actually, the factoring, so that like we would have to factor x minus x to the 5 minus 1, right? So this is going to be factored to x minus 1 times x to the 4 plus x cubed plus x squared plus x minus plus 1. Okay? So how do we know this? Actually, uh, this, this can be easily done by a long division. So if you actually divide x to the 5 minus 1 by x minus 1, that's the quotient. Okay, that's the quotient. But it's also good to remember the pattern though. Okay. So factoring, like, x squared minus 1, x cubed minus 1, x to the 4 minus 1, x to the 5 minus 1, x to the 6 minus 1, it all follows the same pattern, okay? So you don't really, once you remember this pattern, you don't really have to do the long division, each time, okay? Right. So top and bottom have the same factor, x minus 1, so we can cancel it out, right? That leaves us limit x goes to 1, x to the 4 plus x cubed plus x squared plus x plus 1, and the answer in this case is going to be 5. Okay, so we get the same thing. Okay, so that'll be all. Right. So, the more details of it, my discussion here in this lecture note can be found in my lecture note at the following address. Again, this is hyperlinked. Okay, so to get there, you just need to click on this. If you are also interested in what a derivative could mean in physics, okay, here, physics mean like, the say, the basic like mechanics. Please also see my lecture note at the following address. Okay, this one is also hyperlinked, so you just need to click on it to get there. And as usual, if you are interested in getting to, my, the blogger site, where you can find other my other lecture notes. You just need to click on this word blogger, which is also hyperlinked. Okay, folks. Thank you for listening and watching. I'll see you next time. Bye bye.